So welcome to this week 11 in this course on machine learning operations. This is going to be the last of the weeks uh, with a view for sharing new content and new material with you. In the next week, we will actually close out with a summary discussion of various things that you would see in real life, the best practices, as well as some of the newer topics that you might encounter. We might not go into much detail on those newer topics, but nevertheless, um, we will close out in the next week. So, to continue the discussion with LLM ops from week 10, where we left off at that time was to look at how you can build your own fine tuned model and accordingly pay attention to the data processing, ensuring that the quality is right, ensuring that the formats are conducive for LLM architectures to pick up, like we saw with the IRIS data set. The assignment for you was converting from the numerical to a linguistic data set so that it can learn effectively the patterns associated with the different classes. And we also briefly touched upon CI/CD aspects of LLMs, specifically about what are the patterns associated with both pre-training and fine-tuning before the usage, and then after the LLM goes into production, um, the usage of the LLM for inferencing. So in this week's lecture, we're going to take a look at all the considerations associated with running LLMs in production, and this becomes the critical aspect of closing out the knowledge associated with LLMs, right? So let's start with one of the most important attributes of what defines an LLM and its usefulness, which is actually accuracy. So does the LLM generate responses that are usable, that are correct, that are relevant for the specific task? That's how accuracy is measured, right? Unlike the classical ML model, where the accuracy is mathematically definable and verifiable, here the natural language interface naturally provides variance, right? Provides uncertainty around how specific concepts are described, how certain values are responded with, etc. So, how do you even understand what accuracy means? So, to put it in a bit more detail, there are three types of evaluations which are possible. One would be um, the set of benchmarks that you can use, which are either general purpose or which are domain specific. The second would be where you can use a human, and the human looks at the output and verifies whether the output is at par with what he or she would expect if they were interacting with a human, or if the values are accurate, for instance. And the third approach would be to use other LLMs to step in and become the judge. So, evaluate and critique the output of the current LLM. So, the general purpose benchmarks, we will spend some time in the next couple of slides. The domain specific benchmarks are, however, lot more valuable because they are naturally domain specific. So, they are very tuned to what you want to achieve or what you want to try to do. In practice, you will find domain specific benchmarks give you more bang for the buck. So, the effort required to build them is something that's very much worth it, because the places where generalized LLMs, like the ones which are very popular that you see out there, the places where they tend to hallucinate or tend to come up with incorrect responses are also the places where domain knowledge is heavy. So, if you work in a domain constrained setting, meaning that the domain information is critical, encourage you to come up with benchmarks for that, which are, you know, very suitable for what you want to do. The good part is the general purpose benchmarks are, uh, capable of being extended to become domain specific benchmarks. So let's start taking a look at them. So one of the most important and active benchmark available for LLMs is this language model evaluation harness. So this is a benchmark from this company called Eluther AI. I hope I'm pronouncing the name correctly, but the link is available here. It's a GitHub repo. It's open source. It's available for anybody to use. It's meant to be a collaborative benchmark. which everybody can contribute to. And the best part is, given the active interest in this field, there are already enormous numbers of benchmarks and categories of tasks available within this. So, what's the harness itself? The harness is a unifying framework that allows for any causal language model meaning a language model which predicts the next token given the current set of tokens, to be tested on the exact same outputs or other inputs and code base, so that you can meaningfully evaluate the performance of a model against another, right? So this helps you establish what's the ground truth, and it also helps you establish relative performance characteristics of models, right? So this works for both self-hosted models like the ones that we just did in week 10 and we're going to do in week 11 as well. But it also works great for commercial APIs. Let's say, for instance, the GPT-4 API from OpenAI. There are already 60 plus standard academic benchmarks, which means these are benchmarks which have been released into this community by academia. They've been vetted and verified. They're actively used. Research papers get published based on that, etc. And these are associated with various tasks as well as languages, right? You will see, for instance, the harness supports um, instruction tuning, benchmarks in French or Arabic or other languages, for instance. But it also supports different types of tasks like contextual question answering, contextual understanding, summarization of documents, etc., etc. In fact, one specific benchmark within this, uh, it's such a vast collection of benchmarks. One specific collection of benchmarks is something called as Big Bench. Um, Big stands for Beyond the Imitation Game. It's a tongue-in-cheek reference to the movie Imitation Game, but it's more uh, a play on the fact that early days of LLMs, people mistakenly assumed that it's just regurgitating whatever it knows, right, from prior history that it's read or that it's been trained on. Whereas modern LLMs are doing much more than that, right? They're doing agentic workflows and things like that. Nevertheless, the Big benchmark allows you to test out LLMs on a variety of standard tasks, like close to 200 plus standard tasks, like question and answering, summarization, etc., etc. So, if you work in the field of LLMs, either as a user or as a fine-tuned model producer, or even in the rare case, the foundation model producer, you have to be aware of this benchmark framework. You've got to use it, and you've got to actively evangelize it as well. So that's with respect to the language model evaluation harness. Once you have a harness like that, what can you measure, right? Obviously, you can measure things like accuracy, the ability to recall certain pieces of knowledge, etc. Um, let's put method to this, right? So there are effectively 4 ways in which you can improve LLM accuracy for a fine-tuned LLM. So remember, I'm not talking about going from foundation to fine-tuning. That's already happened in week 10, so to speak. Here we're talking about taking a fine-tuned model and improving the accuracy even more using lower cost interventions. So one of the most emerging class of techniques, it's what's called as post-training. So post-training is just a catch-all for what happens after the fine-tuned model is produced. So what can you do with that, right? At that stage, without changing the weights, without having to go through epochs and iterations of training the final layer or anything else, you can still tweak some things and arrive at better accuracy from your LLM. So there are 3 specific techniques. The first is called supervised fine tuning. Here I'm giving small numbers of pairs of input output responses, right, which are ideal. So this gives a very good anchor for the LLM to train itself further on and use as context for answering your questions. Like for instance, the input output could be um, for the iris example, we already saw what the instruction to the system was, which is classify the flower into one of these 3 types. The input could be um, the flower has a long sepal and a narrow petal. So the ideal response is setosa, as an example, right? So this is an input output pair which gives a very specific ideal response, and it gives supervision, so to speak, of what should be the right response for the specific type of input. So these are examples, think of it that way. So that's supervised fine tuning. The second way in which you can post train the LLM is by giving preferences to what you want as output. So which means you give multiple outputs which are possible, which also the LLM might be thinking about, but you also indicate which output is more preferred, right? Instead of the less preferred response. That's direct preference optimization. And then you've got more advanced techniques which are reinforcement learning based, where you provide feedback such that the model rewards itself in a certain way based on that feedback. So like I said, this is an emergent field, lots of research, lots of very interesting activity happening here. We end up doing supervised fine tuning anyway, right? That's how we've been trained to use, for instance, ChatGPT from pretty early on. So it's just giving proper rigor around those concepts that we already know. So that's post training. The second way in which we can get better accuracy is using prompt engineering. We'll talk about that in a slide. The third way is using lookups from uh, RAG documents. So we saw lookups as one of the most important usage patterns towards the end of week 10's lecture. So what lookups do is allow you to read from known factually correct sources of information which have been provided as documents, right? Basically as a RAG use case, and then use those pieces of information in the context window so that the LLM um, defers to it for factually correct answers instead of making up answers based on prior knowledge, so or past knowledge at the training stage. So that's what lookup from RAGs means. Obviously, it helps you control hallucinations as well, by the way. But more importantly, the broader accuracy of the responses goes up if it looks up from a document which is a known source. So that's lookup from RAGs. And last but not the least is verification layers. Can you put in layers which verify the output? So we'll take a look at this as well in a couple of slides. So let's dive into prompt engineering. So here, the most important, you know, uh, I should say, concept that it's good that will be good for us to understand is that in the modern world with LLMs, the prompt is as good as code, right? We think of it as unstructured text that we can change anytime, and it doesn't really have a structure and blah blah. But actually, it's you know dictating outputs, right? It's influencing how an LLM behaves, and therefore it has a potential to influence the application within which that LLM is running. So you should treat it with the same level of sanctity as code, which means it needs to have the right level of engineering principles, DevOps, CI/CD, etc. All the things that we spoke about before. So you've got to version it, you've got to control it using all the similar practices that we saw, right? Which is Git flow, having a main branch which has the right prompt as a template, etc., etc. So the other major consideration is that a prompt that performs very well, right, which is already tuned for accuracy, um, is naturally tied to the underlying foundation model on which the prompt is running, or the fine-tuned model on which the prompt is running. In other words, the fine-tuned model and the prompt go hand in hand. So you can't take that prompt and apply it to a completely different fine-tuned model and expect the same level of performance. Note, the key difference here is the performance will very likely vary, but the fact that it comes back with an answer which is sort of in the meaningful range is not the problem, right? Like for instance, I've got the iris classifier fine-tuned model with Gemma 3 built out as we did in week 10. You've built a Gemma 2 model, right, as part of week 10 assignment. If you take a prompt from the Gemma 3 model, if you apply it to the Gemma 2 model that you build, you will likely get a response like one of Setosa, Virginica, etc. But you might not get accurate responses, which means you might find that Setosa is the predominant class that it keeps predicting, even though other samples are also given. That's what I mean, right? So the analogy here is, if you look at a database, there is a SQL standard which is applicable for all databases, but that database has extended or specified specific versions of that SQL standard, which works very well for it. Like for instance, certain databases don't support um, outer joins. So in which case, if you write outer joins against a database, it will either fail or it will have very poor performance. But that same SQL syntax will work very well on a mature proprietary database. So the analogy is, a SQL that you write for a specific database, you can't expect it to run out of the box against another database, um, either because it will fail syntactically or it will fail from a performance standpoint. So that's how you should think about it. So prompt is like code, and prompt is very closely attached to the backend foundation or fine-tuned model. So how do you engineer for prompts, right? So first is the aspect of controlling for that engineering. So here you should think about prompts as being housed in prompt templates. Templates provide the overall structure for a prompt while still providing you parameterization so that you can change specific data points within the prompt. So the templates are very good for controlling the marriage of the prompt against the backend model, right? So you don't go haywire with respect to using a template that's not supposed to be used for a specific model. Let's say you built a template for Claude, you want to now use it against GPT-4. You will be prevented from doing that, hopefully, by having best practices around creating templates. So when you create the template itself, you should say, this is a Claude iris classifier template. That way, anybody who uses it will immediately see, hey, that's a Claude template. I should not be using it. Let me use a GPT-4 template, right? So that's an example. The other reason why prompt templates are very useful is it allows you to control for security. So we'll take a look at what are the security problems with poor prompt engineering that might come in. So the good part is with prompt templates, and there are tooling available for you to use with prompt templates, and we'll take a look at one of them in this week 11 hands-on portion. You can now start to track the usage and the responses against this prompt template. And this allows you to, again, do governance on top. So go back to the analogy of SQL queries. If a prompt is a SQL command that runs successfully with good performance, a prompt template is a parameterized query. That's the analogy, which means that parameterized query is already defined to work with very good performance and syntax, which works seamlessly on that database. And what you can do now is come and change values of those parameters and get different answers, right? So the values of the parameters get applied onto the template before creating the final prompt or the final SQL, which then gets executed against the backend model or the backend database respectively. So that's how you can think about parameter values being tracked and recorded for every prompt or every SQL that gets executed in the backend. Like that, the prompt lineage of what prompts input were provided to the model, what was the prompt response, all of that is trackable for governance purposes. So prompt templates are a very useful construct. There's another emerging world of optimization around prompt engineering itself that's come up. One is a useful open source project called as DSpy. So what it's trying to do is come up with a DSL for prompts. So building on this analogy of SQL, right? It's as though you can think about attaching a broad structure to every prompt while still not losing the natural languageness of that prompt, right? So again, if you look at the analogy, SQL itself was a declarative programming language. It was supposed to be easier to use compared to the procedural programming that you would do with C, C++, Java, or Python, um, or the functional programming that you would do with Python or Lisp or anything else. Declarative allowed you to say what needs to be done without worrying about how it needs to be done. Right? That's what separates a declarative from procedural. Now with prompts, we've gone up even one more level to say that, look, I don't worry about the syntax. I still say what needs to be what needs to be done. I don't worry about the syntax. So it looks and feels like natural language. So that's prompts. So it goes a big step above declarative. What DSpy like frameworks are trying to do is not take that big a step, but take a smaller step, which means I still try to put some structure around what's possible to be specified as things that need to be done, while allowing the user to use natural language to specify what needs to be done. So the structure is minimal compared to completely natural language, and it's also a little less constraining than, let's say, something like a declarative. So DSpy is one such framework. What it does is, once a prompt is defined using these structures, then it can organize those structures in different ways so that it's optimized, so that it's controlled. It's an emerging field. I'm sure there are going to be more tools as well in this layer. Okay, verification layers. We spoke about that briefly as one of the other methods available to improve LLM accuracy. So here the LLM is sitting separately, and now you're taking the LLM's response and you're checking that for compliance with either factual accuracy or security related purposes. So which means this is a separate layer, almost like an API, which invokes the LLM for the response and then takes the response and processes it further. So one such example would be a RAG lookup to ensure that the LLM response is factually correct. We spoke about this example before. Another one is to take the response and send it to a critique LLM, which means you have another LLM running, which critiques the response for factual inconsistencies or hallucinations, etc. Now, if you do this for every response or every request response, then obviously it's a waste, because you're dependent then on completely this critique LLM for evaluations, and you're using both the LLMs for every request response, which is like redundant. Instead, if you use the critique LLM on a case by case basis, that's a more practical way to approach this. So in most cases, the critique LLM is going to be something that's usually more powerful than the base LLM that you're using in your application, right? Like for instance, let's say the application is running on your mobile phone and it's coming back with responses on whether there are photos of your family in your G drive, as an example. Now, you're sensitive, let's say, to photos of kids in your family, because that's sensitive information. And for that alone, the LLM has to get the response absolutely right. When that is the need, then the LLM can be used to, the verification layer can be used to defer the response check to a much more powerful LLM which is running in the cloud, right? Which is giving you the right response with better accuracy than the quantized or the smaller LLM that's running on your phone. So that's one example. So you can use another LLM to critique the response. And last but not the least, you can always use static rules as a way to check the format or check the outputs. So what's the example of a critique LLM? Let's take another example here beyond the image example that we just spoke about. So um, let's take an example of a PDF, which is a brochure for a product, right? And the product could be, let's say, a washing machine or a vacuum cleaner. So the prompt is from a user who's looking to buy that washing machine. He says, give me the benefits of this product. Now, he doesn't know there's a PDF, which is a brochure attached to it. So the prompt comes from a user in a, let's say, a chat window on an e-commerce website. Then the prompt gets attached to a PDF. The PDF is the product's brochure. And that attachment happens as part of the lookup API, right? Which is serving that particular request. Now, when the response comes from that LLM, the LLM says, okay, product X is FDA approved, right? And it increases lifespan by 15%, like whatever that means. How do you know that this is correct? So here you can use a verifier LLM, and that verifier LLM is given the same context, which means it's given that PDF, right, in the context window. And the instruction it's given is, given this particular retrieved context from the PDF, does the above answer from the other LLM, contain any information which is not present in this source? If so, go about labeling every one of those sentences as verified, not verified, right, or unsupported. So this is a way to use a critique LLM for, like I said, specific request responses which are critical for you to get right. Okay, so let me pause here, and in the next video we will take a look at the other considerations of LLM ops in production.